divide and conquer approach. Another fundamental, very important problem-solving method, divide and conquer. Yeah. We used it before, but in this module, so we will learn several different ways to use this divide and conquer approach. Yeah. Part A, insertion sort. Another sorting algorithm, insertion. Special property for this algorithm, insertion method. Yeah. 8.1, insertion operation. Yeah. All right. The problem is our old problem, number 4, sort an array. Yeah. Revisited. But this time, we will discover some new property, and when we apply this new property, we will have a new solution. So we apply this, our old strategy. So we use this strategy many times before. Yeah. Start with a simple case. Yeah. All right, so now when we start, we consider the data size very small. Okay, the smallest valid data size n equals 1, right? You have one element. When we start, we consider one element array. After that, we grow the data size one by one each time. Okay, yeah, so we do in that way. Yeah. Yeah. The question, how to connect two adjacent cases? That's actually what we did in module 3, right? Module 3, when we determine the recurrence relation, we use this way. Okay, yeah. So problem size reduction, think about that. Yeah. Here, you know, the reverse way. So we grow the problem size. Yeah. The opposite way of the size reduction. Yeah. But basically the same. Yeah. All right. Working on the problem size in this way, based on our intuition. Yeah. All right. So when we start, we have one element array. It is already sorted, right? One element array, we can treat it as an ordered array. So no problem. Okay, yeah. But the next step, when we have a new element trying to join this sorted array, yeah. So this is a sorted array. But this time, a new element needs to join the ordered array. Then, how do we make a 1, put it in the current array, and make it sorted, make it ordered? That's what we need to do here. Yeah. By one comparison, you can make it work, right? You only need to do one comparison. Compare A0 and A1, you will get this new ordered array. Okay? Yeah. A0, A1. So here you just assume, you know, one is greater than the other. So you get it sorted. So here for simplicity, I just write A0, A1. Okay, yeah, yeah. All right, next step. Now, another new element comes in to join this ordered array, A2. The question, same question. Yeah. How do we make X2, not A2, you know, we need to do some work, right? Yeah. What kind of work we need to do to make A2 join the current ordered array and get a new ordered array? That question. Okay. Yeah. Yeah. Definitely we need to do some comparisons. Yeah. We can do it, right? After a few comparisons, yeah, actually, the worst case, 2 comparisons. So you can see it. For the worst case, 2 comparisons. For the best case, 1 comparison. Okay? Best case, 1 comparison. Worst case, 2 comparisons. You can make it. Ordered, new ordered array. Yeah. Yeah. Here, we can join X2 with current ordered array in some way. Yeah. So, and you can keep doing things like this. Keep doing, yeah. For this general step, make A sub k new element joining the current ordered array after certain number of comparisons, right? Yeah. So this picture, this diagram gives you a new view of sorting. You can see in this way, you can sort this array, right? Yeah, but it's a new view. It's different from our previous views. Yeah. We took different views before. Yeah. This time we changed to a new view. So this view, you look at the actions you take for each step. Is it insertion step? Insertion? You insert A sub k to an ordered array. Can we see in that way, insertion way? The main step we're using here, just the insertion step. How about that? Okay. This new insertion view will give us a new sorting algorithm. That's the new method. Yeah. All right. Add a new element to the current sorted array and then make it sorted. So that's the typical action we take for each step. And this step. Yeah. So we describe it as insert an element in a sorted array at the right position. You need to find its right position first. Then you do the insertion. Or you just do them together. Yeah, do these 2 things together. Find the location, do the insertion at the same time. Yeah. Yeah. If you figure out the details to do these 2 things, then the sorting is done. The whole sorting is done. Okay, yeah. All right. So let us study this insertion operation. So we call this main step for the new method, insertion operation. Yeah. Let's study the insertion operation. Shift elements for insertion using a diagram to visually understand the step. Yeah. Shift elements to the right. Yeah. How do we implement that insertion operation? Yeah. So this tells us how to implement using some visual way. Yeah. All right, so let me draw the diagram. Okay. So we need to do insertion. When we start, we have this picture. Okay. Insert AK to ordered array. But you need to find some room for AK, right? Yeah. There, you need to allocate some location for this new element AK. Yeah. But how to how do you find room for new element AK? Yeah. We use that shift operation, shift to the right operation. Okay, yeah. Assume this arrow place is the correct place, right position for the new element, AK. Yeah. We need to locate it and then do the arrangements. Yeah, all right. To do it, yeah, because that AK in the original given array, yeah, that little AK, before we do the insertion, it is in this location. But we need to lift it up, okay? We need to lift it up. That means we do the copy. We make a copy to another variable location. Copy to, so this is a temp variable location. Okay, yeah, temp variable location. So we copy to a temporary location. Yeah. Then after we make that copy, this location is empty, right? Yeah, its original location is empty. So then we can shift other elements to this location. Yeah. All right. Yeah. Then we do comparison with A sub k minus 1. If A sub k minus 1 is greater than A sub k, we shift it to the right vacant location. Yeah, because we already make its right position location vacant. So we shift it. We shift AK minus 1 to its adjacent right position. Okay. Similarly, for AK minus 2, we do another comparison. If it is greater than A sub k, we shift it to its right adjacent vacant location, and so on. Now, keep doing that until after we make this last shift. This is the last shift because we assume this is the right position. Right position. Okay. Yeah. So we stop. After we make the last shift and A sub k is placed in its right position, then this insertion is done. Yeah, because yeah, although you can try the next one, the next one we assume A next I less than that AK. Okay, so we stop. Yeah, this is the with stopping criteria. Stopping criteria. Right? Yeah. Yeah. After that, we do not need to do any comparisons. So we just stop. Okay. So this is the visual understanding of the insertion operation. Okay. Yeah. All right. So then the last one, yeah, because you find the location and you make it vacant, right? Yeah. So this one is available now. Available now, you just copy that temporary location A sub k, that temporary location value to the right position, right location. Yeah, you complete one insertion step. You just repeat this insertion step again and again. You can get a whole array sorted. That's the whole procedure of this insertion sort. Pretty simple, right? Yeah. Using your intuition, imagination to understand this procedure visually. All right. So we get this new sorting algorithm. It is called insertion sort. All right? Yeah. So after that, yeah. So the number of assignments, yeah, big theta of k, yeah, big theta of K. Yeah. You have the best case, you have the worst case, right? The best case, 1, right? The best case, 1 comparison. Yeah. After you compare with A sub K minus 1, it is greater than sub K minus 1. So you put it back to its original location. You're done. Insertion completes. Yeah. But the worst case, you need to compare with all the elements in the current array. That's K comparison. Okay, yeah, K comparison. Yeah. But if we use the asymptotic notation, we can use that big theta of K.